open loop position control. So this is the block diagram, and follow the parameters value based on table 3.1. So the first step, we need to check the block diagram whether can be functionate or not. Apply one for input angle and one for alternator gain. As we can see here, both shows the value, so that means the block diagram is functioning. And the second step is we need to increase step by step value of input angle from 0 to 10 and set alternator gain 0. So for this example, I will just show for input angle 1 and input angle 2. So this is 1, alternator 0. As we can see here, the input voltage is 0.6111 and the shaft motor position is 0 because the alternator gain is 0. So change this to 2 and is it have any difference to the block diagram? Yep. So the input voltage is increased from before. So for the step 3, we need to increase step by step again, but for alternator gain from 0 to 10 and set the input angle to 0. So same as before, I will just show for 1 and 2. 0. So for input voltage 0 because there is no input angle here, and even though there is a value for alternator gain, but the shaft motor position is still 0. Change it to 2. Does it have any difference between 1? So we have no differences here. So as we can see, if there is no input voltage, the shaft motor position cannot be functionated. And lastly, we need to set the input angle for anti-clockwise and clockwise for 5, 10 and 360 with the alternator gain 1, 5 and 8. So for this, I will just use 5 for input angle. So positive 5 shows the clockwise, and for alternator gain is 1. The input voltage is 3.056 and the shaft motor position is 58.64, which is very large. Change to clockwise, anti-clockwise, I'm sorry. So the input and shaft is in negative value for anti-clockwise. So I think that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, for the closed loop position control, okay, let's construct the block diagram in figure 3.5 using the map simulink. So we already construct it and key in all parameter value in the simulink block. So we already key in also, and check the block simulink by key in the input angle is 1 and if input evaluation for the position display. So just do the for step 3. So this one and to take it is 1. So run. So when so they display for the input voltage and shaft position, and also our voltage also display. So this diagram is function. Okay, next, increase the stop by stop value of input angle from 0 to 10 and set the alternator gain 0. Observe the shaft motor position display and what happened. So when we put the 0 in the input angle and the alternator gain 0, also shaft motor position also 0. So 0, 0, 0, and the last one, so 10, 0, equal 0. So we gonna try it. Input angle 10. And this 0. Okay, so the same like the result before this. 10, 0. We get shaft motor voltage is also 0. And for step 5, increase the step-by-step value of automatic gain from 0 till 10 and set input angle is 0. So automatic gain all the result in also 0. So if you want to know it, so let's do the run the simulation. 10, 0, 10 and 0. Okay, 10 and this is the 0 and this is the 10. Okay, after we run this display also the get shaft motor position as of 0. Okay, for the step 6, set input angle 5, 150, 360. So for 5 we're gonna do the only 3 in here, 5 and 1. So 5, 1. This input angle is 5, input gain is 1. So we get the input voltage 3.056 and shaft motor 3.927 and output voltage is 2.4. So it's same also. And about the clockwise, when it's negative, the all result is negative also. So same like before. So for the clockwise, 150 and 5 in here. Okay, 150 and again is 5. So we run, we got the 91.67 for input voltage and 138.5 for shaft motor position and output voltage is at 4.61. So it's same like the result. And also for the negative, we already put the negative also. And for the 360 and 8, so input angle 360 and total gain is 8. So run, we get input voltage 220 and shaft motor position 311.9 and output voltage is 190.6. So same like a result. And for anti-clockwise, it will put the negative only. So this is a percentage error. Calculate percentage error between the input voltage as a set point and shaft motor is an output. So output minus with the set point, divide the set point and multiply it by 100%. So our average for 6 result is 14.16%. So that's all for the SBD2. Thank you.